Morning, April 20, 2020, another day of life and another day of hardship on world over, never expected before, but life is moving on turmoil in such a way never expected before. No other way out, no other way in. Everything has to move as it is. No answer to solutions. Only trials and errors moving world over. Trials and errors moving world over. Now, for this, just a glimpse of a house, a PowerPoint presentation, for architectural, structural, elevations, and certain kind of concept. Being shown here. This is general arrangement drawings for some house, say 500 square yards or 420 yards in square meter. You can see various sketches are being shown to you. Various details. You can read the titles are written there, because I am showing you through mobile, so I can't read directly from here. This foundation, beam plans, it is showing reinforcement details, continuous foundation, and you can see structural framing. Then another floor, and another floor, stair. Then name of house, and you can see elevations, driveway, and then front, then from distance remote and the building with that, and then another view. Then another view from further distance. Just this internal elevations of balcony, another internal detail. You can see this is internal, front elevation internal, basement stair, or basement, another internal, outside, elevation front door. This is again so this is that sketch. Now this is a view. I'll give you another one. Some projects I'll show you. This is again I'm showing this plant. You see, this is an ethylene plant, 600 kTA capacity. This It's a plant covering about 2 kilometers by 1 kilometer size. And you see big process area here. I'll show you components of these plants. And components are cracking furnaces. This is cracking furnaces. Cracking furnaces here. And this is ethylene. Facilities ethylene. This is the facility area. The process is ongoing. There is onshore project, processing plant. I am trying to keep all this in the beginning so that people know what I am talking about. All this structure and all this. And this another one is there are various process plants. Intake. I am going to show intake from C, then C. Then some other areas called administration area, and then process area, and then seawater. Basically, there are 4 structures shown in this, 4 locations. One is at C, that's called C intake. Then there's administration area. After that's process area, and then the seawater basin, where water is stored from sea for purpose of circulating into plants to maintain its temperature. That's all these 4 points. You can see 4 nominations are there, 4 titles are there. I will take on to our the other sketches. This is administration area and warehouse area, and some facilities in between. This is further expansion of administration house, amenities, warehouse area of same project. There's process plant and electric station in this process plant. All these pictures have been taken from Google Earth, just for the information I'm telling you, nothing from sites. So you can also check that. Google is written here, you see. Then it is flare tower, where gases are being exposed, disposed air to atmosphere. The final one, all waste gases are being disposed into environment. You can see this red color, liquid fire. Then it is another landscape of this area. This landscape of administration area. You can see this green color grass, plantation, etc. Hard landscape and soft landscape. Hard landscape, roads, pavement, walkways, and all that. And soft ways is green area. And this is administration and warehouse, both combination. Same landscape, again hard landscape and soft landscape. As I said, hard means where hard material is required, like cobblestone, walkways, footpath, road, seeds, and soft is plantation, irrigation, all that. It's a combination. It is a network of road, and then we go to again. This is pipe racks. You see pipe racks, indication of pipe racks, part pipe, not all pipe racks. This to show up to these pipe racks are also RCC foundations and columns, and on that sitting on beams or structural steel network. After that is process area in a glimpse. You can say process area in a glimpse. Then there is sea water basin, a big basin, big sea water basin, much more bigger in size than a swimming pool. It takes water from sea, stores in air. Big pipe are used to convey this water from sea. I think two numbers 84 inches diameter pipes were used, ductile iron pipes, to procure this water from sea into this basin called seawater basin. Seawater basin, this is where water is stored and circulated to all plants, equipment we are required, and then it is circulated and then disposed after that. This is structural, very big structure in that, open structure, with pump rooms, etc. And if you go further, you'll find substations, electric stations, and roads are in this part plan of this process plan. There's a substation there and various utilities, and you see from this you'll find a part in that. This is your substation here. The substation, this type of building, complete RCC structure in blast zone. Blast because it processes it. Raslafan Qatar it is. Raslafan Qatar, according taken from Google again, Google Earth. These four tanks, and these are LNG tanks. Diameter of one tank is 80 meter, and thickness of and height is 50 meter. RCC tank containment and internal is metallic. Actual tank is metallic. RCC is for purpose in cases of failure. So RCC external is there, and then solid tanks and all others become other plant. This is LNG tanks. It's a very big structure. If you see that one, then go to administrative. This is an electronic record center. This is a small building but very complicated. Electric record center. This is my standby arrangement for protecting electronic record of some plant. And this is in Qatar, also taken from Google Earth. This RCC building, complete landscape. One is here, another one, and about 800 kilometers from there, two standby ranges are there. Then this is firing range or shooting range. This firing and shooting range. This is a training center for army. Is a part of training center. RCC, bulletproof, RCC bullet trap, and many. This is 350 meters long structure. I explained to you in last videos. I'll again just talk of this firing range, shooting range, and this is squadron offices in same area. So it's not very clear what squadron offices there in same area. The plan is not very clear from Google, but it's also saying this is not sorry clear. Google are not taken directly or not allowed. This is army area. So then sports area is another one. You can go to Google and find that. That's no problem. There it is. This is Baghdad in building because there's just Baghdad scene I show you. There's one building that I put red right on. That was a project here, this one. This was a press building, Darul Thawra, that one. And this is city of Baghdad, congested city. See buildings, what quality of buildings you can see from plan itself. This was 1981, 82, and then the same, this press building much more clear than previous previous photo. This is that building, you can see that one. So this is your project. Now I'll take you to, now I'd like to give you something else. Let me go to another one to give you something. Okay, now I would like to show you something here which is very different than this. This is a E-plan which gives circuit of process, how whole process moves. This is actually a technical document giving process. And I also took this down from Google Earth. I mean to say Google, because these are all technologies and they will now tell you what are facts. But actually maybe it's an obsolete diet or something. I will show something else now. Then this is something maybe you have seen before. This is a diagram or you can read that. This is a lithosphere, and I'm sure you know what is lithosphere. Lithosphere is solid part of Earth excluding air. This was a model I developed based on geology. This is giving much details about, if you go through and read that, this you'll find much information in that about layers in Earth lithosphere and what's densities of that, what's depth of that, diameter of each layer in total, and how strain energy is so stored and it works. All this shown in this. This is of course technical, but it is common also because everybody can understand this, how energy works, how it is released, and because of that, how you get earthquake or vibrations in Earth, and what are areas on Earth that support itself for all such actions. It may be danger for us, but we have to understand technicalities of that. Release of strain energy important, and this is the thing. You can see this, there are three layers. One is external one, that's called crust, other one is mantle, and one is crust. And diameter of Earth 35 kilometers from its crust, and its total is 12,500 dia, using up to polar 6,000 something. This complete minute details are shown, collected from various information available, because no original work can be seen. It's all references. And then I go to I'll try to get it something which is very important, but no, let us use the book plans. It is say I'm showing these sketches because all these are coming time. I'll discuss with that. This is kind of township. The township is telling me markup of that, or it contains what is amount is written on that. What it contains actually. It's giving a little information of that, and then it will give some sketches as well. It's giving means titles of those complexes. This is I'll show you. So these are various titles in that. These titles are there for that complex. Various titles. Go further, you'll find more. Some of you are here. I'd like to show a few of them just for can you see this? You just notice what is this? It's a kind of complex unit having such types of apartments in that and contained in its different shape. Varying shapes. The rotation of circle and the shape, another shape in square mode representing something. And also see this one. long buildings of that shape, containing apartments. So this was there actually. This was that, and this is another one. You see, just showing you some examples of it. Say this is one plan. This is a big complex. This shows something rather than that in shapes. A self-contained unit giving some buildings in different shape, and these are ready to some. There is, say, for example, there's another Hindi written. I'll come forward. Let me close this. Just for your information, it was. I actually was searching which lost that figure, I think. This now there are some files which are, say, changing. Title is changing cities building opportunities. This was one paper I submitted. Then there was GGBS PFA title. So I tried to give you some information about this before going further. Yesterday I gave you about tall buildings. So today I'll try to give you about this, changing cities, building opportunities. I'll talk to you this one, and before that, this is title I asked you to know who's there. Let me see what there is. Okay, I could not see that. Sorry. And this is welcome, Mr. Abhi Guru Royal. Okay, thank you. Welcome, Mr. Vinod. Welcome, Mr. Sarma. Okay. Well, it's early morning, so I don't expect many people. Whoever is there, thanks to all of them. Then let's go further. And the purpose, as you know, the purpose of this talk is about management of buildings, management of structures to construct building or structures, not necessarily buildings only, structures which are very important in our life. We cannot live without that. And this is about, let's say, world being a global village. This is long back but still applies. World being a global village requires consideration of uniform development so that its citizens should avail justified facilities which expectation should be realized but it's virtually not feasible. This for example is given here, maybe I cannot directly read from here, that's why I read it separately. I'm showing you text only in this form. So it says, world being a global village, as I said, requiring considerable consideration of uniform development so that its citizens should avail justified facilities which expectations should be realized, but it's virtually not feasible. Second is true. It's true that UNWHD charters outlines requirements of changing cities' philosophies, which looks fine at first glance, but its basic application is far from realization. Actually, this was a day of United Nations regarding cities, changing cities' philosophies, not actually philosophies regarding how to change cities. That was a requirement. So now I say humanity demands justification to avail natural facilities to an equal opportunity basis. But that is merely acceptable within political statement approach only. Everything is not possible practically. So it says humanity demands justification to avail natural facilities to an equal opportunity basis. So it's written here these two paragraphs. I'll move them down. So let's say probably these files may be available somewhere. I don't know. Or I'll put them later on. Now what actually it's saying is that all nations are not economically equal, which impacts on propositions regarding quality of life that may be availed by its subjects. Consequently, citizens from one nation to other have been deprived to avail indicative standard quality of life. Habitation is very significant. Habitation means where we stay, how we live. Habitation is very significant requirement for a person after food and clothing are made available, which should extend opportunity to all sections of society. For concrete fact that about 50 to 70% expenditure goes to construction sector. But what does habitation mean herein? This is written here. That's what I talk about now. What is the meaning here now? Habitation varies from creating an ordinary hutment. Habitation varies from creating an ordinary hutment through various classes of houses, low or high rise, and destined to high profile palaces delivery. Generally, no country had been well planned, while even so-called advanced countries' economies suffer on account of existing virtual slum clusters, though not so designated as such. Bharat is a society of varying classes of people, varying classes of cultures, and varying classes of communities, all dealing with different sets of problems. Bharat as a nation is rich, but majority of its subjects do not enjoy riches or health. So this is in this, you can see that one. So this is true for ours, but it equally applies to many advanced nations, economies whose subjects are not rich in person to own permanent habitation satisfactorily. For national development, a right to shelter is a must, but every must cannot be met. Bharat cannot be solely defined as cities areas only, since as a nation it resides in villages. It's unfortunate that our polity has not been consistent enough. since beginning to help all subjects avail habitation by support of state or society. Simply contemplating on cities and towns development part of a nation can prosper but not society as a whole. I see that. So, simply contemplating on cities and towns development part of a nation can prosper but not society as a whole, and until society as a whole is developed, nation cannot develop. Plans should be charted out in such a way that first basic requirements of a city or a town and villages must be met, while other facts state that millions of subjects in our economy do not even have drinking water, do not have good food, do not have sanitation, do not have adequate health support facilities, and do not have electricity. It is senseless to talk of housing them all, promising them habitation which is not going to be available even in forthcoming decades. Simultaneously, it should also be remembered that population explosion shall not assist positively to provide habitation to hundreds, millions of persons until intensive family. Okay. Somebody should remember the population explosion shall not assist positively to provide habitation to hundreds of millions persons until intensive family planning is achieved, which virtually does not look to be affected due to whatsoever reasons, could be political or otherwise. Yes, we feel pride for having developed many cities, many metros, many high-rise buildings, but at what cost? We have been allowing diminishing agricultural lands and allowed land availability losses. We have been allowing squeezing for future sustainability by spoiling agricultural land. We have failed in national efforts to get water for irrigation as still we bank upon rain and feel threatened when it is either flood or drought in some parts. We fail in preserving redundant storm waters. We fail in preserving redundant storm waters during monsoon that goes waste due to the fact that no river netting could be achieved during last 6 decades. What does it indicate? Do we consider these facts seriously, or we leave it to polity to decide? Yes, cities have been developed nicely. For example, Delhi has got many flyovers, but waterlogging could not be managed till day. Why? Why did engineers allow such designs in first place? Why designers cannot think and resolve to drain out such water accumulations during rain? Why not such sudden logging could be contained by harvesting, by draining out due to down to deep into ground strata? Okay, now why not such sudden logging could be contained by, okay, that's all right. Now why not such sudden logging could be contained by harvesting, by draining out down to deep into ground strata as water return back to normal reservoir, natural reservoir. Whole cities brought to on hold, traffic jams during even after 30 minutes heavy rain. Where do we stand then? Is this engineering development, or we just intend to show ourselves as international without being professional makers? Is it an engineering or development objective to attain by adding a modern flyover, not resolving jams but adding to water logging? Where has engineering gone to? Now, many cities do have added to respective geography so-called modern advanced housing complexes in high-rise columns as buildings, naming them as world-class apartments. What is world-class within such apartments is out of common understanding. Inclusions of swimming pools, inclusions of certain shopping centers, inclusions of certain security arrangements, inclusion of jacuzzi, inclusions of certain high-speed lifts may be referred to for designating such buildings as modern, but is it fine? Are these buildings having loss prevention provisions, fire suppression provisions, evacuation of occupants immediately? Then, are these buildings having fire safety arrangements? Are these buildings having seismic resistance provisions? Are these buildings having adequate parking facilities? Are these complexes having 60% to 70% green areas on ground for respiration, non-polluted air? Are these buildings having adequate electric supply and water distribution provisions based on least energy consumption? Are these accommodations allowed adequate ventilation so that at least during daytime it should not require electrical supply for reading? Are these buildings so designed that air conditioning should be used to a minimum requirement? Are these buildings supplied water by pumping or by gravity? These are many points, you can see that here. My finger is coming here, I think. Yeah. Okay. Now, housing should be such. Housing should be such that habitant has to pay a minimum affordable price. Housing should be within reach of everybody. When we see per square foot covered area price from rupees 2,500 to 5,000, it is surprising. Can we imagine that a person earning even 50,000 rupees monthly may be able to buy such house? Just depending on loans is not a right approach, and even if loan is availed, it is severe headache for occupant to continue for decades due to high interest rates charged involved. So habitation has been thrown into hands of promoters who have made unlimited profits out of such projects, while consumers have to wait for years for occupation. Then price of lands and accommodations both have skyrocketed. A land in Faridabad in 1989 rated say rupees 500 per square yard has gone to possibly rupees 100,000 to 150,000. Is it progressive habitation development or barring habitation of cities? Is it a solution for providing habitation to normal citizens or just habitation got a right only for affluent or haves? We should not think that even high profile professionals working on accounted money only can avail at least a good suitable house in this country. Apart from costing so high, quality and durability of structures do not meet specifications requirements in general, which consideration is very serious. Alright, now quality responsibility must be owned by engineering community as a whole and specifically by civil engineers and architects. Civil engineers are not legally protected under statute, while architects play a respective role under ambit of Architects Act 1972, wherein architects are covered professionally. Every person can assume as an engineer whether or not one is adequately qualified in eyes of law, while fact remains that no such engineer title mandate exists. We can see growth of some mason as a builder, some carpenter as a builder, a layman as a promoter, while engineer begs job from the architect, not from a client. Now, those engineers who are state employees do not face such problems, but practicing engineers do face in reality, and of course, state employees from JE to C job title are considered themselves as engineers, while factually a person responsible in all professional respects can be designated as engineer and others as resident engineers. Engineering practice, however, long experience one would have, has to depend on others for job hunting. Those who work in whatever organization do not practice engineering out owning responsibility, but assisting responsible engineer. Okay, now chartered engineering title exists on national basis. Chartered engineer title exists on national basis under II authority, but it's not mandatorily applicable for public safety by operation of law. Authorities have legislated on an arbitrary basis local bodies registrations for civil engineers, which is not in line to Schedule 12 provisions of Constitution of India municipal authority. Chartered engineers are not well aware of their chartered rights to contest with authorities when such C certification is condoned and departmental registration is demanded. Until adequately qualified engineers involved directly for supervision and prosecution of such structures pertinent all habitation classes, no suitable quality based habitation promotion can be achieved, keeping public safety at risk. Oh, objective of habitation should be objective habitation should not be appointed for money making by delivering substandard housing units, but for welfare of society, including all classes of people. Let us consider an example of Delhi Metro airport tunnel, whereupon 150 houses en route develop cracks on structures caused by vibrations transfer impacts from tubes operation, which shows that no proper soil investigation and stress calculations were conducted prior to finalizing design. Many structures failed on other routes as well, while even in Bombay accidents resulted. Failure reports about other buildings under construction, whether legally or illegally, were received from all over Bharat, which status does not indicate good engineering. Then, despite ours being called the knowledge economy, despite our being called the knowledge economy giving us pride, but should we consider pride or should we feel ashamed of? We are, what are reasons that we cannot professionalize engineers? For industry to care about cost, quality, and time of delivery, which are management requirements in all economies, have been witnessed many failures in other economies as well, but we are concerned about ours. Since we have a large pool of educated engineers at all levels, varying from bachelor to professional and international. Now, apart from all factors, while carrying out development and construction, significant safety factors have been generally neglected. An attempt to talk safety issues to many people reveals as if a joke is made, since SHSES can only be implemented overseas and not in our country. Safety first criteria, with certain exceptions, has been practically unknown to engineers in our country, unfortunately. I do not find difference within schools of thought between sub-Arabs and our citizens to this requirement. Should we not care about human life? What is meaning of physical development? Should we not care of poor and lower middle class and what's meaning of development? Now, it's no use to see a nation in hands of only rich and affluent who enjoy all benefits. Should we develop cities and towns, we should include all sections of society, otherwise, habitation contemplation is based on inconsistent theory. leading to incomplete development. True that engineers on their own are unable to realize as such, but at least quality and safety can be managed by resorting to rigidity during supervision, which does not happen in field, is really an unfortunate state. As a person, I shall not like to be happy should a building housing thousands of occupants provided with all modern and ultra modern facilities but found on accidental deaths of workers who will deliver building through promoter to occupants. And sin sin to construct such buildings for habitation, while society as a whole should be responsible for such bad construction. Development should go hand in hand with development of poor and needy. Generally, while noticing construction activities in cities, rusted steel reinforcing bars are included on structures and further moisture allowed on. Straight reinforcing bars delivered to various areas are bent to avoid trailer transport cost. Construction workers and supervisors are not well trained on concrete technology. Concrete ready-mix plants in general are not professionally managed. Then engineers and supervisors do not bother about concrete parameters during delivery and pouring, while concrete curing is not applied meeting specifications requirement. Defects are repaired to choice of laymen, builders, and sometimes not even noticed. Professionalism on construction procedures look to be lacking qualitatively. Civil structural engineers confined to designing a sphere only, sitting on computers in AC rooms without caring for field non-compliance to construction procedures. Many structural engineers do not release professionally based design, working drawings, and relevant details, leaving side actions on reliability respecting ill-trained personnel for whom design got no concern, leading to waste of designers' attempts, howsoever good design calculation could be. Certainly require professionally trained, traditionally trained personnel to chart out habitation to our cities and villages. Require such leaders who are visionary and care about masses rather than about certain few elites in society. Habitation is a gigantic process for our country due to the fact that there is no end to it. Infrastructure requires development and augmentation to cater for current and future needs. Have to move long distance, probably many decades, to achieve habitation for all objectives for us. Engineers oblige a responsibility to learn first buildings qualities and then teach others who would construct such housing. Architects should attempt to understand buildings from non-aesthetic perspective, which involves structures as well. Engineers, architects, and buildings services engineers should team up for delivering a better product without conflicting with interactive professional statutory functions. As an unfortunate development has affected by certain states, authorities, namely one being Huda, which requires masters in structural engineering for issuing stability certification as a sole criteria, I do not consider, and many of my fellow colleagues shall I agree with it, that more than bare qualification, certificate, practical hands-on experience requires attainment. And keeping all such facts in view, all drawbacks should be corrected. All drawbacks should be corrected, reforming to an opportunity for evolving habitation. Not only improving habitation standards, but also by virtue of added training to production of large pool of real professionals and technicians. Nation can be built only by habitation. Should it be extended to all subjects, for Bharat has got all indifferent problems, issues incomparable to other nations. I request to kindly view slides respecting a small plotted house built in 2010, including design slide. Show me that slide in beginning on this talk. Adequate provisions were made on elevations for natural illumination during sun time, while well designed structures achieved in RCC framing involving a span up to 11 meters. Levels included basements, ground floor, double height, first and second floor. This is just for awareness to use engineering technology with detailed input. This I showed to you in beginning of this talk, and now I like to go to another one, that tall buildings I explained to you. Now I'll go to you to the GGBS PFA concrete durability safety. This is a now there's a material which is very important to be discussed, and it's regarding chemicals, or you can say kind of replacement of cement. I think maybe I told you before and I'm not remembering this. It is production of every ton of Portland cement. See, production of every ton of Portland cement, an essential constituent of concrete, releases about 1 ton of carbon dioxide into atmosphere. This was a talk made. I'll just now explain to you about this. Do you understand what I'm saying? Is a ton of cement, Portland cement OPC we call it, releases approximately equal weight of carbon dioxide, equal quantity of carbon dioxide, which is not supportive to environment, which is against environment. This is that point I'm going to do. Why it is, what solution for that, what you can do to avoid that. That's the point here to discuss with. And it says that the title is, I'll show you that. This is technical, but actually it's not technical. It's common sense documents. It's exactly not technical. It looks technical, but it's very, very important that people should know about this. So now, partial replacement of cement. It's called partial replacement of cement with SCM. SCM stands for supplementary cementing material, reduces greenhouse gas GHG, greenhouse gas called greenhouse gas GHG emissions proportionately resulting in a more green concrete through reduced energy consumption. That is required to produce cement with avoidance of process emissions, which is related to limestone calcination. Repeat, partial replacement of cement. Partial replacement of cement means if you replace cement and place with something else, that is supplementary cementing material, which reduces greenhouse gas, that is GHG, emissions proportionately resulting in a more green concrete, more ecological concrete through reduced energy consumptions. That is required to produce cement with avoidance of process emissions, which is related to limestone calcination. It's a very complicated paragraph, but you look on this. This paragraph is a complicated lecture. Partial replacement of cement, so that's the SCM and GHG. Okay, I'll move further. Additional benefits include minimization of waste disposal by using such materials for landfilling with these industrial byproducts, causing lessened pressure on natural resources, such as reduction in limestone consumption, use for production of cement by replacement of part of cement with SCM. While SCMs are used judiciously, improved concrete properties and durability can be achieved. Repeat this paragraph, is also a complicated one. Additional benefits include minimizing waste disposal by using such materials for landfilling with these industrial byproducts, causing lessened pressure on natural resources, such as reduction in limestone, because limestone is a major part of cement. So reduction in limestone consumption used for production of cement by replacement of part of cement with SCM, that supplementary cementing material. While supplementary cementing materials are used judiciously, improved concrete properties and durability can be achieved. You can see this paragraph also. Additional. This is that additional. And also required for sustainability of available energy. Also required for sustainability of available energy for future generations to come. Sustainable development demands that state-of-art technology should be developed in such a way that current requirements are met, while reservation of energy should also be left available to be used by future generation without any difficulty or causing any unbalancing to natural equilibrium of energies. Again I read this. These are very actually complicated paragraphs. Also required for sustainability of available energy for future generations means we have to keep in mind that we should not destroy whatever we have today. It should be left for next generation who shall preserve further. Sustainable development, that's meaning that tomorrow, day after tomorrow, or in coming time, you should leave it for future generation. Sustainable development demands that state-of-art technology should be developed in such a way that current requirements are met, while preservation of energy should also be left available to be used by future generation without any difficulty or causing any unbalancing unbalancing to natural equilibrium of energy. This, I think I given this one. No, let's check it again. Also, it starts with also. Yeah, also it is this. And further, it's also true that yet a thorough knowledge, it's also true that yet a thorough knowledge or technology requires development to understand certainly all aspects of producing durable concrete. What is understood by article meaning of term durability? Dura- Durability being how far hardened concrete can serve structure, keeping intact all its inherited properties at production time while accepting effects imparted by material hysteresis, including its further adverse impact on reinforcement or other material constituent ingredients. Again, I read this is also a little different. You know, it's also true that yet yet a thorough knowledge technology technology requires development to understand certainly all aspects of producing durable concrete. What is understood by that? Meaning of term durability. This article durability being how far hard concrete or hardened concrete can serve structure, keeping intact all its inherited properties at production time while accepting effects imparted by material hysteresis, including its further adverse impacts on reinforcement or other materials constituent ingredients. It's a little technical, but you can understand that means. Now I'll see actually what it says. It says that we don't have perfect technologies with us, but we have to maintain sustainability, which means whatever is today should be preserved for tomorrow also. Use it today when required and really leave other one, so your generation can do. But question is durability. What do you mean by durability? It says that whatever strength that material is, that strength should not be reduced. That strength should continue for further without any loss of that strength in long term even. That way we have to devise technology that's called material hysteresis. That material hysteresis should not come in and matter should work intent for that duration it was designed. Now come forward. Supervision and quality requirement assurance is also necessary. Supervision of quality requirement assurance is also necessary on concrete production from plant or site mixer to site location. Which part has been missing or undervalued in many areas of globe. Thorough knowledge of concrete durability and other properties require good understanding by personnel working on concrete. In particular, qualified site supervisors, semi-qualified site supervisors, site consultants and site foremen must be trained to understand and apply quality demands to achieve durable status of concrete. Again I read this. Supervision and quality requirements Assurance is also necessary on concrete production from plant or site mixer to site location, which part has been missing or undervalued in many areas of globe. Thorough knowledge of concrete durability and other properties require good understanding by personnel working on concrete, in particular qualified site supervisors, semi-qualified site supervisors, site consultants and site foremen must be trained to understand and apply quality demands to achieve durable status of concrete. In fact, concrete technology has widened. In fact, concrete technology has widened its scope to unlimited levels, yet it is distant from clear understanding by common applicants who are responsible for concrete application, resulting in deliveries of substandard concrete even in areas where good skilled supervisors are available. It's also suggested that engineers should strive to have on front experience to understand concrete technologies in addition to having understanding of office and laboratory activities. Then now what is supplementary cementing material? I'm going to define that. SCM. What is that? Supplementary cementing material. Let me take some. Just a little water. Drink. This today's talk is little maybe you feel it's a little complicated, but it's not complicated. It's common sense talks. SCM, that is supplementary cementing material, means which first of all should understand actually there is no cement as cementing material. We consider cement. That's only for saying supplementary cementing material. Supplementary cementing material are those which are used with Portland cement to contribute to properties of hardened concrete through hydraulic or pozzolanic activity or by both. Typical examples of PFA, that is fly ash, pulverized fly ash, glass, ground granulated blast furnace slag. Ground granulated blast furnace slag. Ground means pisa, ground grains, granulated blast furnace slag. That's called GGBS, so GGF, BBS, silica fumes and natural pozzolanas. SCMs are well developed materials and used properly while mixing concrete. Hardly site is left, some site is left where SCMs are not used. But this is for West countries, not our countries. Supplementary cementing materials are those which are used with Portland cement. I am repeating that. Supplementary cementing materials are those which are used with Portland cement to contribute to properties of hardened concrete through hydraulic or pozzolanic activity or by both. Typical examples are PFA or fly ash, ground granulated blast furnace slag, GGBFS, silica fumes, and natural pozzolanas. SCMs are well developed materials and used properly while mixing concrete. Hardly any site is left where SCMs are not used. Now we have to see about this, what actually these are. What is fly ash? We should have an understanding of that before going further, because without understanding we can't move. A common understanding, it's not very big science, or you can say something, it's little understanding. So now fly ash is finely, not finally, finely divided, very बारीक, बहुत बारीक, finely divided residue resulting from combustion of pulverized coal, that is carried from combustion chamber of furnace by exhaust gases. So fly ash is finely divided residue resulting from combustion of pulverized coal that is carried from combustion chamber of a furnace by exhaust gases. For reference, specifications for use of fly ash in concrete are given in Canadian specifications A3001, which classifies fly ash as F, CI or CH. F, CI or CH by its calcium oxide content, calcium oxide. Now type F, this F refers to fly ash with calcium oxide content less than 8%. This is F according to Canadian classifications. Type CI has a calcium oxide content ranging from 8 to 20. In that was 8, in this 8 to 20. And type CH fly ash has a calcium oxide content greater than 20%. So 8 to 20 and more than 20. Higher calcium oxide content generally denotes higher self-cementing properties. This is definition and classification of fly ash. Means F grade, CI grade or CH grade. F grade means when your calcium oxide content is less than 8%, and CI grade when it is 8 to 20%, and CH grade when it is more than 20%, and it also claims higher CaO, higher calcium oxide content generally denotes higher self-cementing properties. So this is a very important paragraph, as I think isn't that now let's say chemical requirements for reference, right? In this CA, as I said before, CSA A3003 standard permits a maximum of 5% SO3. This is further chemically it's given. This is CSA standard permits a maximum of 5% SO3 content for type F fly ash, and maximum loss on ignition 8%. Maximum SO3 and LOI contents for both types CI and CH 5% and 6% respectively. SO3 content has been reported to influence to some degree early age compressive strength. This is SO3. Now, if you see further, this is said that 5% SO3 content for type F fly ash and maximum loss on ignition is 8%. Maximum SO3 and LOI contents for both types Ci and CH 5% and 6% respectively. SO3 content has been reported to influence to some degree of early age compressive strength of mortar and concrete specifically. That's SO3. Higher SO3 content, higher is resultant early age strength. However, a maximum limit on SO3 is considered necessary in order to avoid annexous sulfate content in hardened concrete, which may contribute to disruptive expansion due to thermal sulfate attacks. So that's also a point. It says a maximum limit of SO3 is considered necessary in order to avoid an excess sulfate content in hardened concrete, which may contribute to disruptive expansion due to internal sulfate attacks. So as it was said 5%, 6% last paragraph, it says limit has to be given. So now go further and see LOI is determined, loss on ignition is determined by mass loss of fly ash heated at a temperature of 750 plus minus 25 degrees Celsius. 750 plus minus 25 degrees Celsius. Unburned carbon is largest component of LOI. Unburned carbon. जो जलाने unburned carbon is largest component of loss on ignition with water required for workability of concretes. Water required for workability of concretes is influenced by carbon content of fly ash. While shape of carbon particle porosity, you can say particles porosity, higher carbon content of a fly ash, more water is needed to produce a paste of normal consistency. Then also doses of an air entraining mixture. Doses of air entraining mixture for fly ash concrete to achieve a certain air content increase with an increasing caution. Also doses of air entraining mixture for fly ash concrete to achieve a certain air content. Air content increases with an increasing carbon content in fly ash used. Carbon absorbs organic admixtures such as air entraining agents. Water demand and doses of air entraining mixtures both increase with increasing porosity of carbon particles. So you can see both paragraphs. Now, physical properties and requirements. These are chemical properties. Of physical is more important than chemical because it's difficult to understand chemical properties. Physical you can understand them. Now, physical properties of fly ash vary over a wide range. Specific gravity, for instance, ranges from low value of 1.9 in some fly ashes to high value of 3. For iron rich fly ash, specific gravity values of normal 2.2 are however common by comparison Specific gravity of Portland cement is minus 3.15. Fineness is one of primary fineness is one of primary physical characteristics of fly ash that relates to pozzolanic activity. It is well known that particles larger than 545 micron show little or no reactivity under normal hydration conditions. It has been reported that pozzolanic activity is directly proportional to amount of particles finer than 10 micron. Figure fineness of fly ash ranges from less than 2% retained to more than 30% retained on 45 MCU. I don't know if you're able to see that because the fonts are very small in this. Okay, now mineralogical composition is also very mineralogical. Mineral, how many minerals are there? What says about minerals? Mineralogical analysis of fly ash typically shows 50 to 90% non-crystalline particles or glass and some crystalline phases. The reactivity of fly ash is predominantly related to non-crystalline phase or glass. Reactivity, that is of concrete. Reactivity of fly ash is predominantly related to non-crystalline phase or glass. Higher calcium fly ash, that is type CH, contains significant quantities of reactive crystalline phases that influence property of fly ash in concrete. Mineralogical composition, this mineralogical analysis of fly ash typically shows 50 to 90% of non-crystalline particles or glass and some crystalline phases. Reactivity of fly ash is predominantly related to non-crystalline phase or glass. Higher calcium, significant quantities. Higher calcium by fly ash, that is type CH, contains significant quantities of various means higher calcium fly ash type CH contains significant quantities of reactive crystalline phases and that influence properties of fly ash in concrete. Now quality control. This mineralogical composition process, see mineralogical composition. Now, quality control. Little complicated this talk is because of technical. It is also very important for technical people. Fly ash from a given power plant. Now we have to deal from where it's coming from power plant. Fly ash from given power plant may vary with time depending on many factors such as changes in burning conditions or source and composition of coal. Variations in fly ash properties may affect performance of concrete. The fly ash properties that are most likely to affect its performance in concrete are fineness. Fineness, I told fineness, particle size or shape. Fineness, particle shape, glass content and composition, loss on ignition, autoclave, expansion, SO3, CaO and alkali contents. Variability of fly ash color should also be monitored for architectural concrete applications. Changes in fly ash color can also indicate changes in carbon contents or power plant burning conditions, which may affect performance of fly ash in air and drained concrete. These are quality criteria that have been given, which are very important. I will repeat for you as to rate quality control here. Alright, then I'll repeat for you. Fly ash from a given power plant may vary with time depending on many factors such as changes in burning conditions or combustion of coal. Variations in fly ash properties may affect performance of concrete. Fly ash properties that are most likely to affect its performance of concrete. Fly ash properties that are most likely to affect its performance in concrete are fineness, particle shape, glass content and composition, loss on ignition, autoclave expansion, SO3, calcium oxide and alkali contents. Variability of fly ash color should also be monitored for architectural concrete applications. Changes in fly ash colors can also include changes in carbon content or power plant burning conditions, which may affect performance of fly ash in air. Ground gravity blast furnace slag. This is a very, very important item, which is actually a friend of cement, friend of weather if it is used properly. But I am sure that so far it has not been allocated its offices in various countries. GGBS name stands as a very big it is, but it is GGBS. Name is very simple. Ground glass, ground granulated, all that. Now what to do? This is let's see here. I can read from here, I think. Let me try from here. Ground granulated blast furnace slag GGBS. Ground granulated blast furnace slag GGBFS is a non-metallic product. This is not metal, non-metal. Consisting essentially of silicates and aluminosilicates. Silicates and aluminosilicates of calcium and other bases. Developed in a modern developed in molten conditions, developed in a molten condition simultaneously with iron in a blast furnace, with followed with followed by water chilling rapidly to form glassy granular particles, then ground to cement fineness or finer. Now, once again I read this because it's important. Ground granulated blast furnace slag, GGBFS, is a non-metallic product and is a non-metallic product consisting essentially of silicates and aluminosilicates of calcium and other bases. Silicates and aluminosilicates of calcium and other bases. Developed in a molten condition simultaneously with iron in a blast furnace, followed by water chilling rapidly to form glassy granular particles, and then ground to cement fineness or finer. In concrete, GGBFS reacts with Portland cement to form cementitious products. Slag processes both cementing and pozzolana properties. Let me show you first what is this. Alright, no further. Chemical composition, as we said before about PFA. Chemical composition compared to fly ash, this GGBS is usually rich in calcium and magnesium oxides. For similar reasons as mentioned above in fly ash, CSA A3000 limits SiO3 and sulfuric content in GGBS to 4% to 2.5%. Then compared to fly ash, GGBS is usually rich in calcium and magnesium oxides. For similar reasons, as said in fly ash above, CSA limits SO3 and sulfuric contents in GGBFS to 4% and 2.5% respectively. Physical properties and requirements. Chemical composition can read first. Physical properties and requirements. Unlike fly ash, GGBS is ground to desired particle size on surface area. That's important here. Whatever size you desire on design, It is real that time I'm with you and we talk together. Uh, you know, Unlike fly ash, GGBS is ground to a desired particle size or surface area, specific surface area, you can say, depending on degree of activation required as well as economic consideration. It is reported that slag, slag particle size less than 10 microns Alright, this is very interesting actually. A specific area you can increase, means you ground further, don't wait like BFA, depending on degree of activation required as well as economic consideration. It's reported that slag particles less than 10 micrometer, 10 micrometer, 10 microns what? Okay, it's reported that particle size less than 10 micron contribute to early strength development up to 28 days. Particles in 10 to 45 micrometer range continue to hydrate beyond 28 days and contribute to later stage strength, while particular above 45 micrometers generally show little basis or no activity. This is very basic difference of this, means this works up to 28 days, then 10 to 45 microns work up to 28 days, and further down it works up to 45 further this. So let me repeat this complicated para to avoid your confusion. And unlike fly ash, this metal GGBS is ground to desired particle size or surface area. Depending on degree of activation required as well as economic consideration, reported that slag particle less than 10 micron contributes to early strength determination. Now, up to 28 days, that's 10 micron contribute to strength development up to 28 days, and 10 to 45 micron range continue to hydrate beyond 28 days, and 10 to 30 days. Okay. Typically, in order to obtain satisfactory strength development on concrete, plane surface area of GGBS range from 4,000 to 6,000 centimeters. So this is figure actually. Plane surface formula given a plane. Typically, in order to obtain satisfactory strength development in concrete, plane BLAINE plane surface area of GGBS ranges between 4,000 to 6,000 centimeters square per gram. This point you have to understand, very important point, it's typical point. This is that one. Plane surface area means it is saying if you take one centimeter per gram 1 gram sim this TGBS and rub on something so that it's completely goes on some surface, length is a big one, and then measure it. What was difference now and difference where? So that way you can say 4,000 to 6,000 centimeters square per G. In order to avoid disruptive expansion of concrete contained GGBS due to MgO content, CSA limits maximum autoclave expansion to 0.8%. Mineralogical composition, and here I keep and read it for you first. After taking a drop of water, I'm not feeling all this guy. I don't know why I'm thirsty again. Mineralogical composition. This analysis of GGBS samples show glass content ranging from 80 to 100. 80 to 100%. As with fly ash, reactivity of GGBS is strongly dependent on glass content. That is mineralogical analysis of GGBFS samples show glass contents ranging from 80 to 100%. As with fly ash, reactivity of GGBS is strongly dependent on glass contents. Blended hydraulic cements. Blended hydraulic cements can include various proportions of one, that is binary, 2 ternary, or 3 quaternary. SCMs such as cement can be used with additional fly ash. Let me go again. Such as blended hydraulic cement. Blended hydraulic cement can include various proportions of binary, that's 1, 2 is ternary, 3 is quaternary. SCMs such as fly ash, GGBS and silica fumes. These cements can be used with additional fly ash, and say it's like add it to concrete for life, add it to concrete batch plant. So this is blend hydraulic cements. Now aggregate. There are many reports indicating that alkali aggregate reactions can be mitigated by proper use of fly ash or GGBS. Proper amount of these SCMs There are many reports indicating that alkali aggregate reactions can be mitigated. Alkali aggregate reactions can be mitigated by proper use of fly ash and GGBS. But Proper amount of these SCMs is controlled alkali aggregates reactions in concrete, which well planned will depend on reactivity of aggregate and should be determined through a testing program. Aggregate, you read that here. I read it for you again. There are many reports indicating that alkali aggregate reactions can be mitigated by proper use of fly ash or GGBS. Proper amount of these SCMs to control alkali aggregate reactions in concrete will depend on reactivity of aggregate and should be determined through a testing program. Chemical admixtures used in concrete incorporating SCMs should conform to codal requirements. In determining quantities of admixture to use, SCM is usually added to mass of concrete. Now, air and training agent until in general the doses of air and training admixtures required for concrete to achieve a certain air percentage wise now let's say air entering agents. Says that keep it standard and read better. In general, doses of air conditioning admixtures required for concrete to achieve certain air percentages content increases with an increasing fly ash content, increasing fineness and loss on ignition value of fly ash. It also marginally increases in some cases with increased slag content and fineness. Now, why water reducers and superplasticized high range water reducers? Water reducers, I mean, we talk now. This is, let me put another fan, I think. You see how this fan works. So, as I said, let me finish first. In air and training again, in general, doses of air and training and mixtures required for concrete to achieve certain air percent contents increases with an increasing fly ash content, increases fineness and loss of ignition, increasing fineness and loss on ignition value of fly ash. It also marginally increases in some cases with increasing slag content and fineness. Water reducers and superplasticizers, high range water reducers. In general, that's called HRWR, high range water reducers. In general, fly ash increases workability of a given mix, while water content can be reduced to achieve a given workability. What says when you are adding fly ash, this increases workability of a given mix. Workability means how can you use that concrete mix safely, comfortably until it is placed into its position. That's called workability. Means, for example, water cement ratio, how much water should be there in in comparison to cement quantity. There is a limit to that. That's called workability. Means it should be enough to mix concrete comfortably. It should not be excessive one. Also, it should not be lesser one. That's called workability. So in this case, in general, fly ash increases workability. When you are adding fly ash in place of cement, workability is increased, and says of a given mix, while water content can be reduced. Water content can be reduced to achieve a given mix. Fly ash, when added, water reduction can be achieved. So for GGBS, water reduction depends strongly on fineness. Because there is a control on GGBS, fineness can be increased. So GGBS water reduction depends strongly on fineness. Fineness can be controlled in case of GGBS, while it cannot be controlled in case of fly ash. We have a privilege and liberty here, and using GGBS, the fineness can be increased, and fineness means it's a more specific area. That I said 1 gram of this is put on this, so you guys certain when 1 gram finishes, how many centimeter square it's given. No compatibility, says the 4 GGBS water reduction depends strongly on fineness. Fineness can be controlled in case of GGBS, while it cannot be controlled in case of fly ash. Now, no compatibility issue have been found between fly ash, slag, and commonly used type of super processes. However, compatibility tests are recommended, especially for SCM concrete with low water to cementitious material ratio, water cement ratio, typically lower than 0.35. Now we'll go further. If you want to see, I'll show you page water reduces. You can get benefit of that. Now next, accelerators. Accelerators is this use of low calcium fly ash. Use of low calcium fly ash and to some extent high calcium fly ash. And GGBS generally decrease early age strength of concrete, particularly in cold weather conditions, compared to normal Portland cement concrete with similar workability and similar 28 days compressive strength. So initial setting is delayed. Then say because we are using use of low carbon fly ash and to some extent high calcium fly ash. And GGBS generally decreases early age strength and concrete, particularly in cold weather conditions, compared to normal Portland cement concrete with similar workability and time, similar 28 days compressive strength. Accelerators can be used to partially compensate for this early age strength reduction. However, calcium chloride is not recommended as an accelerator for concrete with high volume of fly ash or for reinforcement or pre-stress concrete. So now, concrete design considerations. What should be design considerations for concrete? Effects of SCM on concrete properties. We are understanding now designs of material. Actually, this is not structural design. This is how to design your material, how to use it in designs of concrete. This is indicative talk. This is not very long talk. We'll just tell you what we do in field. So that what we do is safety on this. This. Now, fly ash. It says properties of fresh concrete as well as its mechanical properties and durability shall be influenced by inclusion of fly ash as replacement for Portland cement. An extent to which these properties shall be affected would depend on nature and proportions of fly ash used. Outlines of manner in which fly ash shall affect properties of concrete in general. That's what's given here. Properties of fresh concrete according to that. Slump and workability. Slump and workability. It's generally known that partial replacement of Portland cement by fly ash in concrete reduces water requirement to obtain a given consistency or increases workability and slump for a given water content compared to that of concrete without fly ash. Phenomenon is generally attributed to spherical shape and smooth surface of fly ash. Particularly phenomenon generally attributed to spherical shape and smooth surface of fly ash particles as opposed to angular cement particles. Particularly in manufacture of precast concrete, workability improvement and concrete can download and upload. Let me see a little further. Phenomenon generally attributed to spherical shape and smooth surface of fly ash particles as opposed to angular cement particles, particularly in manufacture of precast concrete. Workability improvement can result in elements with sharp and distinctive corners and edges and with a better surface appearance. Let me read again. This property of slump and workability, this is very important because on this depends upon how to operate on concrete. I'm getting a gas. Well, it is generally known that partial replacement of Portland cement by fly ash in concrete reduces water requirement to obtain a given consistency or increase workability and slump for a given water content compared to that of concrete without fly ash. Phenomenon is generally attributed to spherical shape and smooth surface of fly ash particles in opposed to angular cement particles. Particularly in manufacture of precast concrete, workability improvability can result in elements with hard and distance occurs. Particular manufacture of precast concrete, workability improvement can result in elements with sharp and distinctive corners and edge near with a bit surface appearance. Now, bleeding, bleeding, bleeding. It's not bleeding that one, but there's also bleeding. Bleeding of fly ash concrete depends on manner in which fly ash is used. I'm playing here. Bleeding of fly ash concrete depends on manner in which fly ash is used. When fly ash is used as a direct replacement for cement with no reduction in water content, bleed water of fly ash concrete generally increases. When fly ash is used as a direct replacement for cement with no reduction in water content, bleed water of fly ash concrete generally increases. However, when a reduction of water due to use of fly ash as a replacement of cement in concrete is made to maintain similar activities or workabilities, bleed similar resulting however, air is trapped sometimes in body. This causes a problem. I do not walk in home. I do not walk for many days. However, when a reduction of water due to use of fly ash as a replacement of cement in concrete is made to maintain similar workability, bleed water of resulting fly ash concrete is generally lower than that of concrete made without fly ash. High volume fly ash concrete at low unit water content does not bleed. High volume fly ash concrete, when you are putting more, high volume fly ash concrete at low unit water content does not bleed. This generally creates a problem for finishers of flat work surfaces who are used to work with more bleed water at surface during finishing. As with any concrete, particularly with a low water to cementitious material ratio, care is required to prevent plastic shrinkage, cracking at surface immediately. After placing concrete, by following required measures or measures on hot weather concrete, plastic cracking occurs when rate of evaporation Let me see again. See, sometimes it's difficult to explain fully because a technical statement. I'll read it for you again so that you can understand as much as possible. High volume fly ash concrete at low unit water content does not bleed. This generally creates a problem for finishers of film from flat work surfaces who are used to work with more bleed water at surface during finishing. You must have seen that. As while any concrete, particularly with a low water to cementitious material ratio, care is required to prevent plastic shrinkage, cracking at surface immediately. After placing concrete, by following required measures on hot weather concreting. Plastic cracking occurs when rate of evaporation at concrete surface exceeds rate at which breakwater replenishes water at surface. So this is an autogenous temperature rise. Autogenous temperature rise. Use of calcium fly ash. Use of low calcium fly ash as partial replacement of Portland cement in concrete shall generally contribute to reducing temperature rise in concrete compared to Portland cement concrete. This is too important on application in massive block concrete to reduce potential for cracking associated with excessive thermal gradients. High calcium fly ash depending on total alkali content may increase temperature rise. Use of low calcium fly ash as partial replacement of Portland cement in concrete shall generally contribute to reduction or reducing temperature rise in concrete. Temperature rise in concrete compared to Portland cement concrete. This is too important an application in massive block. Concrete to reduce to potential for cracking associated with excessive thermal gradients, high calcium fly ashes depending on total alkali controls. Okay. Autogenous temperature rise of setting time. Let me see also one point here. This is too important an application massive block concrete to reduce potential for cracking associated with excessive thermal gradients, high calcium fly ash could be only okay. Setting time similar 28 days compressive strength and workability. Setting time of fly ash concrete may be longer than normal Portland cement concrete for a given combination of cement and chemicals, and thereby an admixture for similar 28 days compressive strength and workability. Setting time of fly ash concrete may be longer than normal Portland cement. Okay. Cement concrete for a given combination of cement and chemical admixtures. This may influence schedule of finishing horizontal surfaces, particularly at higher levels of resonance. This may influence schedule for finishing horizontal surfaces, particularly in layers of lubricant. Now, this may influence schedule for finishing horizontal surface, particularly for finishing horizontal surfaces, particularly at high level of replacement, say 30%. And on cool weather, it, in this case, using a doses of water reducer in lower limit of range proposed by manufacturer can contribute a decreasing to some extent initial setting time of fly ash concrete. So let's say this will influence schedule for finishing horizontal surfaces, particularly in high level of replacement and in cool weather. In this case, using a doses of water reducer in lower limit of range proposed by manufacturer can contribute at decreasing to some extent initial setting time of fly ash concrete. However, this should not be all at once. Now, however, in this case, using a dose of water reducers in lower limit of range proposed by manufacturer can contribute at decreasing to some extent initial setting time of fly ash concrete. However, this should not be at expense of strength, development and durability of concrete. Still, in hot weather conditions, extended setting time can be beneficial. Concrete accelerators may be used to offset increase in setting time when using fly ash. Now, mechanical properties. What is mechanical properties? Strength development. How does it work? That's what I'm going to see. How does it work on structures? Strength development. Strength development of fly ash concrete is strongly affected by type of fly ash. Strength or development of fly ash concrete is strongly affected by type of fly ash and cutting temperature. Use of low calcium fly ash generally decreases compressive strength of concrete on 28 days early ages and increases at later ages due to pozzolanic reactions of fly ash when compared to Portland cement. Concrete with similar 28 days compressive strength. On other hand, use of high calcium content has a marginal effect on strength development. In cool weather, low temperature generally slows down chemical reaction between cement and water, and therefore strength development of concrete for ashes concrete. This effect is more pronounced in mixture and greater dependence of pozzolanic reaction on temperature. However, concrete with fly ash can be proportioned to achieve similar one-day strength as Portland cement concrete mixture by judicial proportion of mixture. Says, however, concrete with fly ash can be proportioned to achieve similar one-day strength by judicious proportioning of mixture. Then this usually requires a materials ratio, water cement ratio, reduction factor given. Right. Then This usually requires a reduction in water cement materials. Ratio is water cement material. Reducing being greater with higher levels of SCMs. It should be now this usually requires a reduction in water to cementous materials ratio WCM reduction being greater with higher levels of SCM. It should be noted that reduction in strength might not be as pronounced in present case. Where heat curing, where it should be noted that reduction in strength might not be pronounced in precast concrete where heat curing is used. A reduction in early age strength also can be reduction in merely early strength. Then it should be noted that reduction in strength might not be as pronounced in precast concrete where heat curing is used. A reduction in early age strength can stop. Then it should be noted that reduction in strength might not be pronounced in precast concrete where heat curing is used. Heat curing, I will just say autoclaving actually. Reduction in early age strength can also be partially compensated for by incorporating silica fumes with fly ash to produce a ternary blended cement or by using suitable accelerators. Young modulus of elasticity. Since modulus of elasticity of concrete is related to compressive strength in general, effect of fly ash on elastic modulus of concrete is smaller, is similar to effect of fly ash on strength development. Therefore, elastic modulus of elasticity fly ash concert is generally lower at early ages and higher at later ages than that of concrete made without fly. Now, drying shrinkage. It was about curing before. I said therefore plastic modulus of fly ash concrete is generally lower at early stages and therefore elastic modulus of fly ash concrete is generally lower at early ages and higher at later age than that of concrete made without fly ash and having similar 28-day compressive strength. Drying shrinkage. Effect of fly ash on drying shrinkage. What is drying shrinkage? First of all, also says where the concrete it starts, the water will leave it, and later it starts setting in. That's drying shrinkage. As much as it dries, effect of fly ash on drying shrinkage is highly dependent on how concrete to be proportioned. If full advantage is taken of reduced water demand and unit water content is reduced, and if WCM water cement ratio is also reduced to achieve strength of parity in 28 days, fly ash concrete shall have some significantly reduced shrinkage compared to Portland cement. Impact of fly ash on drying shrinkage also depends on maturity of concrete when drying commences. If drying starts one day, fly ash concrete may shrink more, and hence importance of proper curing of fly ash abnormal is indicated. Now, creep. Effect of fly ash on creep is mainly related to effect that fly ash has on ultimate strength of concrete. Since fly ash increases ultimate strength of concrete due to pozzolanic reaction, creep of fly ash concrete is generally lower than that of a concrete is generally pozzolanic reaction. Creep of fly ash concrete is generally lower than that of a Portland cement concrete, and with works with let's say creep of fly ash concrete is generally lower than that of a Portland cement concrete with similar 28 days of compressive strength. However, if fly ash concrete is fly ash concrete is loaded at loaded for what? Alright. Let me read it again. Effect of fly ash on creep is mainly related to a fact that fly ash has on ultimate strength. Now, durability characteristic. Durability is a very important point. Remember, durability character. Let me show you this durability characteristics, which is also very important. Little boring, of course, I know, to this talk, but it's a very important one from engineering point of view. I'll just keep it durability and close it. Corrosion resistance. Incorporation of fly ash within concrete results in finer pores. That's important. Incorporation of fly ash within concrete results in finer pores in hydrated cement paste, leading to a decrease in permeability and chloride's ingress rate. This means chloride ingress rate is reduced, not increased, because of decrease in permeability. Is it? If there is decrease in permeability, means passage of movement is closed. This means chloride ingress rate should also close. Properly proportioned fly ash concrete subject to adequate curing or curing should. So incorporation of fly ash within concrete results in fine reports in high-grade cement paste, leading to a decrease in permeability and a chloride ingress rate is reduced. Properly proportioned fly ash concrete subject to adequate curing should in general be less permeable at later stage and then correspondence. Alright, now I'll go to another point, that is properly proportioned fly ash concrete subject to adequate curing should in general be less permeable at later stages than a corresponding Portland cement concrete having similar 28-day strength, resulting in better corrosion protection for reinforcing steel. Fly ashes shall generally increase chloride burning. Let me go again. It's very important. Properly proportioned fly ash concrete subject to adequate curing should in general be less permeable at later age than corresponding Portland cement concrete having similar 28 days of strength, resulting in better corrosion protection for reinforced steel. Fly ashes shall generally increase chloride binding, leading to further improving resistance to rapid chloride penetration, resistance to freezing and thawing. Freezing thawing what means? बर्फ का जमना, बर्फ का पिघलना, both are there. Resistance to freezing and thawing. Cycling of concrete is not affected by use of fly ash. Resistance to de-icing, freezing and thawing. Will say resistance to freezing and thawing. Cycling of concrete is not affected by use of fly ash. This property is a direct function of air void spacing factor of concrete that is obtained by proper use of an air entraining admixture. However, fly ash concrete must have adequate strength prior to exposure to freezing, as in case for normal Portland cement. Now, resistance to de-icing, salt scaling. Laboratory test data shows that fly ash concrete containing more than 25% fly ash is less resistant in general. Low calcium fly ashes have however, some field data have shown acceptable performance of concrete incorporation more than 40 to 50% of fly ash. Laboratory test data indicates that fly ash is less resistant to de-icing salt scaling than Portland cement concrete. However, some field data have shown that acceptable performance of concrete incorporating more than 40 to 50% fly ash. Sulfate resistance. In general, low calcium fly ash have been found to increase sulfate resistance of concrete. However, this may or may not be so with highly calcium fly ashes. Alkali silica reaction is a very important point. Say very important point is that alkali silica reaction, and in general, inclusion of fly ash can mitigate expansion. Inclusion of fly ash can mitigate expansion caused by alkali silica reaction in concrete. This is what we are talking of. Alkali silica reaction, ASR. Inclusion of fly ash can mitigate expansion caused by alkali silica reactions in concrete. However, amount of fly ash to be used for controlling alkali silica reaction depends on type of reactive aggregate, exposure conditions, alkali content of concrete, type of fly ash, and water to cementing materials ratio of mixture. Published data indicate that percent replacement of okay. However, amount of fly ash to be used in controlling alkali silica reactions, because alkali silica reactions is something which in general inclusion of fly ash can mitigate expensive cost by alkali silica. Okay. In general, inclusion of fly ash can mitigate expansion caused by alkali silica reaction in concrete. This means alkali silica can cause expansion of concrete. However, amount of fly ash to be used for controlling alkali silica reaction depends on type of reaction, aggregate, exposed, aggregate, rotation, so expansion of concrete can be saved by adding PFA to concrete. So type of fly ash, however amount of fly ash to be used for controlling alkali silica resistance. Now, another point is regarding fly ash. Published data indicates that percent replacement of cement by low calcium fly ash required to mitigate alkali silica reaction may range from 25 to 35%. For highly calcium fly ashes, there is some indication that effective replacement levels may be. Let's analyze this more. What it actually says is very important to understand. We have talked about alkali silica reaction, and we have talked about relation of that to 25 to 35% of peak BFE. That relation we understood that it helps in solving that resistance to that increases when we use 25-35%. In the expansion of concrete doesn't act. Now, what is carbonation? That's another point. Carbonation. Use of fly ash decreases. Carbonation means use of fly ash decreases permeability of concrete. Inhibition says easy penetration of carbon dioxide into concrete. Says use of fly ash decreases. Use of fly ash decreases permeability of concrete, inhibiting easy penetration of carbon dioxide into concrete. That's a big point. Carbon dioxide in concrete, and it says fly ash decreases permeability of concrete, inhibiting easy penetration of carbon dioxide into concrete. However, it also reduces calcium hydroxide content of concrete. These are little very complicated terms that I am telling you. Penetration of chlorides means corrosion. If chlorides enter concrete, it leads to corrosion of steel. That point is very important. From this is technical discussion, therefore I am going slow. fly ash decreases permeability of concrete, inhibiting easy penetration of carbon dioxide into concrete. However, it also reduces calcium hydroxide content in concrete due to pozzolanic reaction. Consequently showing an increased propensity for carbonation. Also, fly ash concrete usually takes longer to reach same level of strength as concrete made without fly ash. Therefore, not properly cured fly ash concrete may carbonate more than Portland cement concrete. That's the point here. Not properly cured fly ash concrete may carbonate more than Portland cement concrete, particularly at higher replacement levels when carbonation is likely to be an issue. Concrete with high levels of SCM requires extended curing and or reductions in water cementing material. Do you understand that? Again, I can repeat, this is a very complicated arrangement here. Use of fly ash decreases permeability. If you use fly ash, decreases permeability of concrete, which inhibits easy penetration of carbon dioxide into concrete. So, carbon dioxide is now not going, that's plus point. However, it also reduces calcium hydroxide content in concrete due to pozzolanic reaction, consequently shows an increased propensity of carbonation. Also, fly ash concrete usually takes longer to reach same level of strength as concrete made without fly ash. Therefore, not properly cured fly ash concrete may carbonate more than Portland cement concrete, particularly at higher replacement level when carbonation is likely to be an issue. Concrete with high level of supplementary cementing material requires extended curing and reducing production of water cement. So better enhanced curing for longer duration, that can save your problem. Durability in marine environment. Permeability is considered a major significant factor affecting durability of concrete in seawater. It's evident that fly ash has good potential to improve concrete durability in marine environment provided it is well cured. Fly ash has good potential to improve concrete durability in marine environment provided it is well cured. So GFS slag, now I'm talking properties of fresh concrete as well as its mechanical properties and durability. Durability shall be influenced by inclusion of slag as replacement for Portland cement. An extent to which these properties shall be affected depends on percentage of slag used and its fineness. Description outlines manner in which replacement of Portland cement by slag affects properties of concrete. Properties of fresh concrete is slump and workability. GGBF improves workability and cohesion of concrete, but greater improvement is obtained with higher GGBS content. High value fine GGBS does not improve workability of concrete. Greater improvement is obtained with higher GGBS contents. High value of fine GGBS does not improve workability of concrete. Now, bleeding use of slag or this GGBS does not have a significant influence on bleeding of concrete. Alright. Autogenous temperature rise. Use of slag may reduce autogenous temperature rise in concrete. Use of GGBS may reduce autogenous temperature rise in concrete element as well as associated risk of thermal stress and cracking. If sufficient large percentage of slag or GGBS being used as a partial replacement for Portland cement to an extent to say 50% provided slag is not ground to very high fineness. Very high fineness not done, let's say 166,000 lane. Higher levels of replacement may be required for concrete in warm weather conditions. Now, setting time. Setting time of slag concrete may be longer compared to Portland cement concrete, particularly in cold weather. Slower set shall depend on reactivity of slag and its percentage use. This may influence schedule for finishing flat work surfaces, particularly for high volume replacements such as more than 40%. Due to its slightly slower strength development, slag concrete is more sensitive than conventional concrete to cold weather conditions for concrete placing. This may further slow setting time of slag concrete. In warm weather conditions, setting times are similar to those of Portland cement concrete. Mechanical properties. This is very actually important. I'm trying to tell you this is very important from very many points of views, because this is related to environment. We can reduce release of carbon dioxide by reducing OPC and adding GGBS. Strength development. It's not ordinary talk, it's very specific talk about GGBS and PFA, and is that higher. If you study 1 week completely thoroughly, you'll get lot. If you just even on Facebook, the Facebook is not exactly, you should understand face of this material, face work of this material. It will look that it's very slow in beginning, but at end strength is similar, but it gains other properties like prevention of cracks and better casting, workmanship in better, strength in long term is better, and so many other positive issues are related. So we are saying let's know more and more about this from this viewpoint, because OPC was well known and nowadays OPC is not actually being used. GGBS gains strength. Concrete containing GGBS gains strength more slowly, tending to have lower strength at early ages and equal or higher strength at later stages compared to that of Portland cement concrete of smaller, similar 28 days compressive strength. Okay, In general, concrete containing GGBS gains strength more slowly, tending to have lower strength at early ages and equal or higher strength at later ages compared to that of Portland cement concrete of similar 28 days compressive strength. However, at an equivalent replacement level, effect is comparatively less than that for almost fly ashes. In hot weather, a strength gain can be as high or higher than Portland cement concrete. Well, I was just thinking of this material, how can we utilize further, how could this explain better. In my views, when I was just lost, slightly slower strength development, and resulting lower strength, early age strength of slag concrete might be a problem for form removal in some cases when high percentages of slag are used, particularly in cold weather conditions. As for fly ash is concerned, this can be overcome by a judicious proportioning of concrete mixing, such as reducing potassium or adding silica fumes to produce a produce a ternary plant. Now, drying shrinkage. No significance on drying shrinkage in this case when GGBS is used as part of seamless material. The paste contains same. Also, advantage may be taken of improved workability. Workability is improved, of course. Associated reduction achieved what GGBS. Creep. GGBS appears to reduce creep, which is better. Reduce creep due to increase in ultimate strength and elastic modulus of concrete with GGBS. However, if concrete is loaded at early stage, creep might be higher than that of Portland cement concrete due to lower variance of now creep appears to reduce creep due to increased ultimate strength and elastic modulus of concrete with GGBS. However, if the concrete is loaded at early ages, creep might be higher than that of Portland cement concrete due to lower gain of early strength. But doesn't matter, this creep due to durability factor, corrosion resistance. That is more important than something else. Corrosion resistance, usually GGBS in concrete, which increases its resistance to chloride ion penetration. That's most important. Reduction of chloride ion penetration. Inclusion of GGBS in concrete increases its resistance to chloride ion penetration. Particularly at later stages, it also improves chloride binding, which is very advantageous for protecting reinforcing steel from corrosion, for which requirement is that slag concrete is well cured, as mentioned for fly ash concrete. Hence, chloride binding stays, which is very advantageous for protecting reinforcing steel from corrosion. Means penetration of chlorides may not work. Then resistance to freezing and thawing, as is said in PFA case. What happens here? Resistance to freezing and thawing cycling of concrete is not affected by use of GGBS. This property is a direct function of air void spacing, factor of concrete, that of property of direct function of this of wide spacing air wide spacing factor of concrete that is obtained by proper use of air and draining and mixture. However, concrete must air adequate concrete must have adequate strength prior to exposure to freezing, as is case of normal Portland cement concrete. Resistance to de-icing salt scaling. Okay. As for fly ash concrete, laboratory data indicates that slag concrete is slightly lesser. As for fly ash concrete, laboratory data indicates that slag concrete is slightly less resistant to de-icing salt scaling than Portland cement concrete, which limits the percentage of slag that can be recommended in concrete flat work exposed to de-icing salts to less than 50%. Although there are some contradictory results on this issue. Okay. Now, sulfate resistance. Sulfate resistance means that's also very important requirement. But should we do that? No. Concrete containing GGBS dosages greater than 35% by mass of cementitious material has demonstrated an improvement in resistance. Concrete containing GGBS dosages greater than 35% by mass डिस्टर्ब करता है सारा पूरी आपको by mass of cementitious material has demonstrated an improvement in resistance to sulfate attack. For equivalent performance to type HS cement, slag levels of 35 to 65% may be required depending on Al2O3 content of slag. Increasing slag levels would be required with increasing Al2O3 content of slag. Let me read it again. Someone disturb. Concrete containing GGBS dosages greater than 35% by mass of cementitious material has demonstrated an improvement in resistance to sulfate attack. For equivalent performance to type HS cement, slag level of 35 to 65% may be required depending on Al2O3 content of slag. Increasing slag level would be required with increasing Al2O3 content in slag. So generally if it is more than 35%, generally we use 50 to 70%, and generally 70% is international standard these days. If this is reached in hotter conditions requires more, so SRC is not in fact required. So resistance to alkali silica reaction, we talked before about PF in alkali silica reaction. Inclusion of slag in adequate percentages, usually more than 35, can be used to mitigate expansion caused by alkali silica reaction. So that also is gone. Again, saying carbonation. As for fly ash concrete with GGBS, if not properly cured for many days, alright, so alkali silica reaction resistance, inclusion of slag in adequate quantity, more than 35%, can be used to mitigate expansion caused by alkali silica reaction. Means they are also same position as same position. 35%, 40%. Then you go to carbonation. As for fly ash concrete, concrete with GGBS, if not properly cured, now carbonation as for fly ash concrete with GGBS, if not properly cured, may carbonate more than Portland cement concrete. Marine environment durability. Permeability is considered major factor affecting durability of concrete in seawater. Therefore, it's evident that GGBS has potential to improve concrete durability in marine environment, particularly given slag performance in chloride environment. Now, this is a table gives summary of GGBS effects, fly ash and GGBS. Summary of general effects of FALs, LIS, summary for GGBS. Summary of general effects of fly ash and GGBS on concrete properties. Comparison with Portland cement concrete with similar 28 days compression strength. So this is actually okay. I have taken head of it. I'll show you how to do it. Let's squeeze this. There are properties which are compared, and these are fresh properties of water demand. This in fresh properties means when you receive concrete, in that case, water demand, water bleeding, setting time, autogeneous temperature rise. Then mechanical is saying compressive strength, flexural strength, modulus elasticity, drying shrinkage, scrape. And durability is saying permeability, corrosion resistance, sulfate resistance. These are generally compared with this according to this program. So it is water demand, let's say it's acid form. In water, there are also his case Collins suggests one is this properties, what properties second one is that about GGBS, then is saying this written comments, and this is all came about. I'll show you exactly. Same will go like this, you know. So we have shown you what actually it is. I'll read from here for you better. Now, water demand, it says GGBS and comments here. It says that comments fly ash water reduction decreases with increasing fineness and carbon contents of fly ash, and this is GGBS does not have a strong effect on water demand. That's difference. Now, workability. Workability is fly ash. Spherical particles shape of fly ash assists in improving workability because of it's global, or we can say spherical particles. Then GGBS does not have a strong effect on slump but increases pump ability. Then bleeding, how bleeding works here. Fly ash bleeding and strength are in general reduced, and the fire bleeding, and then this is bleeding. Fly ash bleeding and segregation are in general reduced to pump ability improved. However, low bleed water increase risk of plastic shrinkage and alright. Now, fly ash longer setting time compared to normal concrete, which may affect finishing schedule cold weather, and condition may further slow setting times. GGBS, its effect on setting time is less than that of fly ash. Fly ash generally reduces risk of thermal stresses and cracking. GGBS may reduce risk of thermal cracking at least 50% is used, and Blaney finance is lower than 6,000 centimeters square per gram, and if at least 65% is used in warm weather. So warm weather 65%, cold weather 50%. If we say that risk of thermal cracking of at least reduced risk, you can say, in this case of GGBS, and fly ash generally reduce risk of thermal stresses and cracking, especially type F and CI. Then it's called autogenous temperatures. Then mechanical properties are compressive strength. Fly ash decrease mechanical properties at early age, especially one day, and cold weather longer term. Mechanical properties such as compressive and fractional strength and modular elasticity of fly ash concrete is typically superior of modular cement. Now, GGBS similar behavior to fly ash concrete, accepts that concrete has higher early age mechanical properties and lower term mechanical properties compared to fly ash and concrete. Similar. Then fly ash long term drying shrinkage and creep of fly. Then cement concrete of 728 days. Cement concrete of 28 days compressive strength. CGF agreed on reduce creep or now. These are general properties, and there are also, these properties of durability, permeability. This is permeability Fly ash reduces water and chloride penetration, especially okay, but low battery staying battery now. So low battery battery only. That's problem here, low battery staying. So alright, so I can't take it here because no battery. I do it from here. Fly ash says, I was talking about permeability, yes. Fly ash, hold on, yes. Fly ash reduces water and chloride ion permeability, especially at later stage if well cured. Fly ash reduces water and chloride ion penetration, especially at later stage if well cured. GGBS similar to fly ash. So, in the case of corrosion resistance, fly ash increases protection of reinforcing steel from corrosion if well cured. GGBS are similar to fly ash. So, other property is sulfate resistance. Fly ash use of low calcium fly ash, CSA fly ash, FNG with CaO content less than 20% increases resistance to sulfate and attack of failure as to sulfations and this here thing. So fly ash, use of low calcium fly ash, CSA, FY and then you can say CaO content 20% less than 20% increases resistance to sulfate. Ca content less than 20% in case of fly ash means sulfate resistance is attacks. Fly ash with more than 20% CO should be investigated for sulfate resistance only. Really using Kerala. Okay. GS GGBS content required should be investigated. More than 35% is required. Okay, now this is a knowledge document. I think this continue further, and this is IP relevant knowledge contribution. This is GGBS. I now go to other one here. Same document. Now concrete mixture proportions, this is something else. Concrete mixture proportions. Welcome Mr. Detari and Mr. Sajid Saif. Okay, I'll take that in the voice and forward. Okay, thanks. Alright, now it's saying, let's say, it's very typical today. I'm just trying to give you, yes, concrete mixture proportions. Procedure for selection of mixture proportions used for Portland cement concrete is also applicable to concrete incorporating inclusions of either fly ash or slag with some modifications. Estimation of mixing water and selection of air content. Selection of water to cement materials ratio, water cement material ratio to meet durability and strength parameters, calculation of cement content, calculation of coarse aggregate content, calculation of fine aggregate content, selection of admixture doses, adjustment for aggregate moisture, trial batch adjustment. These steps will be dictated depending on method used for incorporation of fly ash or GGBS in concrete. Simple replacement method. This consists of direct replacement of a portion of Portland cement by fly ash or GGBS on one-for-one basis, either by volume or by mass, which mainly consists of modifying an existing Portland cement mix to include fly ash or GGBS without other adjustments. Concrete designed with this method usually has lower performance compared to that of concrete made with Portland cement only. Method now modified replacement method. This was simple replacement. Modified replacement method consists of developing fly ash or GGBS concrete mixture with similar workability and similar compressive strength to that of Portland cement concrete at a specified age. In general, these concretes have a higher total weight of centimeters and consists of developing fly ash GGBS concrete mixture with similar workability and similar compressive strength to that of Portland cement concrete at a specified age. In general, these concretes have a higher total weight of cementous material and low cement than that of Portland cement. Estimation of mixing water. As mentioned earlier, use of fly ash and concrete generally reduces water demand required to achieve a certain level of workability, when use of GGBS does not significantly affect water demand due to fact that fineness cannot be controlled by keeping to determine limit degree of granulation. Therefore, for each type of fly ash and fly ash contents and same thing for GGBS to same extent, data should be developed to replace values for different types. Selection of WCM and see what else is there. Maximum water is our table results will talk later on. This is about fly ash GGBS. Okay, this is a long document, but still I will take it tomorrow then. Alright, now I'll take up this in this page. This is a very long page. I'll take a break on that and come back to other one, which is quality assurance requirement. That's very important one. And I remember, and you also remember where I was last time. No, it's not much time left, yet I'll say something. I remember what we were doing last time was doing something. Now I'm more inclining this way, that item number 628, item number, this is checklist for firing and shooting range works, item number 27, and we talked of this. Now we are going to talk very different way in these items, and that is for, you can say, checklist for formula. There is combination of these checklists now. This combination like this. Say item number. Before that, let me see what I can do. Before number, I just remind where I ended last time. I stopped last time at checklist for firing and shooting range works. Item number 27 it was, and how it was, I will say. It was 300 meter long, 25 meter wide range, and there were some components like main building is RCC framed structure, indoor pistol range is RCC framed structure, outdoor shooting range RCC framed structure, bullet trap chamber RCC framed structure, target pits every 100 meter RCC framed structure, underground passages pits every 100 meters RCC framed structure, baffle walls RCC ordinary thick walls 6 to 4 meters high, gantries supported on PTFE bearings mounted on corbels, structural steel armored plate with waterproof board covering, sand trap. And then these are main components of that. Then what is referred to as attached sketches about firing. I showed to you that day sketches from book. Remember that sketch I showed to you. These are special structures. Bullet trap chamber, RCC framed structures. Target pits average 100 meters, RCC framed structure. Underground passages, pits every 100 meters, RCC framed structure. Then baffle walls, RCC ordinary thick walls, 6 to 4 meter high. Then gantries. So voice says means gantries supported on PTFE bearing. PTFE you must know, polytetrafluoroethylene, PTFE, polytetrafluoroethylene bearing mounted on corbels. Corbel is a support extended from wall itself, small support. Structural steel armored plate with waterproof board covering. This was that one, and I think I should show you discuss so that you can easily understand that what I'm talking of. And I think it's somewhere here. If I can show you, it will be fine for your memory. It will take just a minute, or I'll show you that. I remember that. Just a minute. Just a minute here. That what it was. You think these are the structures, these are details here. So that is, this is bullet trap on left side here. Bullet trap, and on right side is this shooting point here. Shooting point starts here from floor level. There's a building I have shown in this longitudinal section, and there are passages at every 100 meters down. This is longitudinal action showing you. See, first passage is 100 meters, and second is 200 meters, third 100 meters, and then there is this is underground. There's a passage here. This is steps there you see, and root tunnel else, and this is blood trap, sand fill in, and then above earth fill above sand, so earth fill and then sand above. RC structure, very long structure, and this is again pit here. Then these are further details of that plan. If you see this pit plan, you can see pit plan on this side like this, kind of like this. These are structural detailings of this, and also if you see the structural detailing of this, these are further detailings of that. This is cross gantry. This is gantry on carbon, as I said. This is carbon here. This is baffle wall, it is called, to stop bullet goes out of that. And these are racks for rifles storing, and that's here. Armor plate details here. We'll say this cross gutterized, so to cross truss on which is fixed this details of armor plate, and this is actually cross section of that. Here is, this is your building. If you see from left entry here, left is entry, then it is entrance, and then this is area where you can use, and then after outcome outside you come in this building. And then see, just to show you, this is actual passage of our page. This is this is building here. Building, if you go this way, this building is here. This one I'm talking about, this one. This building then goes to other one here. Continuation of it terminates here, it continues other one. Direction goes to the arrow, goes like that. It both, so arrows are shown, the arrows is shown, other arrows is shown. So this ends here at end where you see at top this bullet trap chamber, which is here this one here. So this in 3, because of page length not available, it is shown like this. This is what I am talking of, and what are structures here showing. This structure shall take our attention, and as I said here that now this will be clubbed up in coming talks. Now I'm dividing these talks in different way. Item number 6, we talk preparatory works for something in item number 6. Now this is concrete pour, that exactly foundation footing concrete pour. I'm going to explain about concrete pouring. This in relation to preparatory works we talked, and that was foundation. Item number 6 we talked foundation, footing, concrete pour. Now 28, the 6th and 20th combination. So plan adequate number of foundations, this was required when we are talking concrete pour. Plan adequate number of foundations in one go to meet RMC delivery requirement. That's important. You cannot order for one foundation. You have to plan such a way that adequate number of, good quantity of many cubic meter of quantities, so that at least one mixer truck should come, truck mixer, maybe 2, maybe 3, maybe 4, maybe 10, depends upon quantity you are having. So planned in a way that adequate number of foundations in one go to meet RMC delivery requirement. And then book concrete in advance to facilitate RMC, supplier to chart out RMC plans schedule, and book concrete of required boom length. Have a site appraised by RMC, let him see site, or if you know, just tell him where it is, let him come and see your site, visit the site. Have site appraised by RMC representative for assessment of timings. Footings, pouring is fast activity, which point has to be considered, and they consider, they know what this is, maybe I will not know. Then prepare, says footing, pouring is fast activity, so which point has to be considered. Prepare pouring platforms wherever required. Do not take any safety risk. If you take safety, you will meet accidents. Maybe you yourself are involved. Think for everybody. So footing, pouring is first activity which point has to be considered. We prepare pouring plans, pouring platforms wherever required. Ensure pouring inspections to is over. Lecture is over. Then concrete temperature should not exceed 30 degrees. Ensuring pouring inspection is over. Ensuring pouring inspection is over. Now, point is, we say concrete temperature should not exceed 30 degrees Celsius in hot weather for concrete pouring, either in early morning hours or late evening or at night hours. Make sure supporting arrangement should not disturb during pour. Make sure vibrator and standby vibrators are available. Then you can say, in hot weather, plan for concrete pouring either in early morning or late night. Make sure that supporting arrangements should not disturb during pour. Make sure vibrant and standby vibrators are available, and make sure mason's tools are available. Make sure vibrators and standby vibrators are available, and make sure adequate number of carpenters and steel fixers are all in attendance for meeting certain low profile emergency, and make sure all arrangements regarding curing are available, and make sure certain concrete testing equipments are available either directly or by laboratory, and make sure that these equipment include slump cone, cube molds, thermometers, air voids, measuring instruments. Make sure that a qualified technician is available to test and record all observations. Make sure RMC delivery timings are correctly recorded. Make sure that no RMC truck starts port advisory. Then make sure the train group of gang to receive pumped concrete is available at location of concrete. Then make sure that qualified technician make sure that make sure that now group of gang to receive pumped concrete. What's that? Train group or gang to or crew to receive pumped concrete is available at locations of concrete, particularly prior to commence with pouring. Have vibrator checked for operations. Make sure that location is cleaned well prior to pouring commences with. Check that concrete location is watered well to avoid flash setting. Receive RMC truck after testing clearance and start pouring from pump station. Footings can be poured in one go, should depth not exceed 400 to 450 mm thick. Footings can be continuous in case beams are cast monolithic. Make sure that no start bars are displaced during pouring. Make sure that concrete occupies all space around rebars and form. And then make sure concrete occupies all spaces around rebars and forms. Make sure that no starter bars are displaced. Concrete occupies all spaces around rebars and forms. Then immediately after top of concrete is level, means we have started concrete already. Concrete and see now compacted as well. Now concrete is working. You have 500 problems there. Anybody of us will change. Like that, It's common practice not to order last top. Immediately after top of concrete is leveled and say half and over is over, curing compound could be sprayed depending on site situation and weather temperature. No gap should be allowed during pouring for a better pour quality. So many, you have to think a lot on that, not simply layman job, it's technical job. So label that and check timing, check gap. If there's a gap, it can cause a problem of cold joint. No gap should be allowed during pouring for better pour quality. It's common practice not to order last truck since exact quantity of mix is unknown or not known. Therefore, hold last truck to replace its order after major pour is over. Make sure that construction joint is correctly formed by roughening, or scabbling. Testing technician must collect cube samples and record all testing observations. Apply Asian or gunny rolls and polythene sheets over unformed surfaces and cure with water all times for at least 7 to 10 days depending on weather conditions. Then make sure the curing management is not thrown away by fast winds. Hardened concrete should not be allowed to let's say testing, then application and all that 7 to 10 days curing, and make sure cutting arrangement is not thrown away. Curing arrangement is not thrown by fast winds. Hardened concrete should not be allowed to dry any time till cutting is over. Side forms can be removed after 24 hours. This is general statement on this. But curing is curing, work is work, concrete is concrete, preparatory works. It is your choice how to do it. I just gave you a simple statement on curing, on concrete pour. I can repeat that so that you remember. Don't depend on documents all the time. Keep in your mind what's to be done. That's more important. What something is written in your mind, that is your learning. You can become an author of that. That's very important point. I repeat that. Item number 6. There's preparatory works at this item. There's concrete pour. Plan adequate number of foundations and one go to meet RMC delivery requirement. Book concrete in advance to facilitate RMC supplier to chart out the RMC plant schedule. book concrete pump of required boom length, have site appraised by RMC representative for assessment of timings, footings, pouring is fast activity which point has to be considered, prepare pouring platforms wherever required for safety purposes, ensure pouring inspection is over and ITP signed off, concrete temperature should not exceed 30 degrees Celsius in hot weather plan for concrete pouring either morning hours or late evening hours or at night. Make sure that supporting arrangements should not disturb during pour. Make sure vibrator on stand by vibrators are available. Make sure mason tools are available. Make sure adequate number of carpenters and steel fixers are in attendance by for meeting certain low profile emergency, and that is make sure all arrangements regarding curing are available, and make sure concrete testing equipments are available either directly or by laboratory. Make sure these equipment include slump cone, cube, cold thermometers, wide measuring instruments, air wide measurement. Make sure qualified technicians are able to test and record all observations. Make sure RMC delivery timings are correctly recorded. Make sure that no RMC truck starts pouring delivery at site without clearance from testing position is given. Make sure that train group or van or crew to receive pumped concrete is available at location of concrete prior to commencing evening with pouring have been checked for operations prior to going check. Okay, make sure that the location is cleaned well prior to pouring commences. Where check the concrete location, water well, divide flash setting, receive RMC truck after testing clearance and start pouring from pump station. Footing can be poured in one go and should be done not exceed 400 to 500 mm. Then footing can be continuous in case beams are cast monolithic. Make sure that no starter bars are displaced during pouring. Make sure that concrete occupies all the spaces around rebars and forms. Immediately after top of concrete is leveled and say half an hour is over, curing compound could be sprayed depending on site situation and weather temperature. No gap should be allowed during pouring for a better pour control. Alright, no problem. So make sure construction joint is correctly formed by roughening or scabbling. Now it's a common practice not to order last truck. No gap should be allowed during pouring for better pour quality. Hold on last truck since exact quality is not known. Therefore hold last truck to replace its order after major over. Make sure that construction joint is correctly formed. Then make sure that construction joint is formed. Testing technician must collect cube samples and records all testing observations. Apply Hessian or gunny rolls and polythene sheets over unformed surfaces and cure with. So we'll see this later on, these activities, because I want to discuss this in great detail. You must get full benefit of this, and ultimately this is going to be used in your career, not something else. That's important point here, and I think today I discussed something technical as well as this. Actually, my intention was to confer with you on this, but that is also very important because what is concrete actually we are doing these days. These people of this country are not clear. In fact, I think we are not all clear here. That's the point here, and that's the improvement to our corrosion improvement is there. If you are using GGBS or PFA, forget PFA, at least GGB is very important, which is controlled one, which is ground to your requirement. You can increase fineness of your that. Just like cement is very fine, you see, specific area by plane of can take that also as specific area increase fat. The ultimate is the same. There's a delay in early stem which can be compensated, but surface is good, crack prevention is there, and moreover, this enhances the durability of concrete, which is also very important factor. You need not worry about corrosion because already this works supposed for it prohibits the chloride penetration to that, and if you still are not sure, then you have to apply some treatment on that. You can apply it, or you can use epoxy coated reinforcement along with this, which works much better than something else. There are so many ways. It depends on where you're working. You're working in some areas cathodic protection is applied, then epoxy coating cannot be used. If in some areas which no cathodic protection, you can use seashore particularly. But there's chances of seawater penetrating your concrete, then epoxy coating is very reliable solution there. If you got that one, you get it epoxy coating. If you have that type of steel, I think it's available all over the world. It depends upon demand. If demand is there, you can use that. And if you that type of you use that type of you have that preference, you can say that you are going to work for your engineering and for your, in this type. This option is with engineers. Option is also doesn't cost much. How to qualify your work to better status, how to enrich your quality, how to enrich your value on that. Concrete is not one that it goes for years and decades and it has to serve for that period. And if you are not putting quality criteria and the quality content, then how can you say I should work? With this I'll take closer tomorrow. We'll go further than that one. I was talking a knowledge file of this GGBS PFA technical file, and also this in combination too, because I want to disseminate practicality of engineering technology of concrete, not just theoretical. Theoretical, there are thousands of engineers here who know theory and formula and software, but that is only start of engineering. That's not engineering. If your software does very good design, you feel very good, but if it is not worked on site, then there's no meaning at all. Work should be seen on site with quality. That's important. And this would thank you very much, gentlemen. I'm going to close this now. Okay.